Hello and welcome to the topic of memory segmentation in 8086 microprocessor. These are the features of 8086 microprocessor. So the important thing to note is that the data bus has a size of 16-bit, the address bus has a size of 20-bit. So parallelly 16-bit of data can be transferred between the memory and the microprocessor, and to access that memory you will require 20-bit address lines, and that we'll be discussing in this video. This is a small representation of the memory, how it looks like. So you can see the small square boxes. Each square box represents one memory location. So inside one square box, you can see there are 8 bits. These are held by 8 flip-flops, and each memory location is having 8-bit information. So as you have studied, maybe studied in 8085, if you have studied, it has 8 bits data lines, and in 8086 there are 16-bit of data lines. So basically what is happening is that in 8085 microprocessor is able to access one memory location, because it can access only it has only 8-bit data lines, so it can access only one memory location. But in 8086 you have 16 data lines, so it is able to access 2 memory locations at a time. So this makes 8086 much more faster, much more powerful than compared to 8085. So basically what is happening is that when the microprocessor wants to fetch an instruction, it generates a 20-bit address. This 20-bit address is given to the memory, and memory now knows which memory location has to be targeted. Then from the data lines, what happens is that the memory will put out 2 memory locations of data that is 16 bits long and give back to the 8086. So logically we divide the memory into 4 segments. The first is the code segment. So code segment is where you will put your main program. So a microprocessor is supposed to do a function, it's supposed to do an operation, and the operation what needs to be done by the microprocessor. As a programmer, you will be feeding the code, and that code will be stored in the code segment. The second segment is the data segment. So when you are executing your program, there might be chances that you need some kind of data, and if you need some kind of extra data which are not part of the main program, you can store it in the data segment. So if you require some kind of reference voltage, some kind of reference value, you can keep it in the data segment. Then we have extra segment. Extra segment is very same as the data segment, but what we do is that there are 2 things you can do. One is that you can store your results in the extra segment. If you want to organize it in a better fashion, you can put all your data in the data segment and put all your results, all your calculation results in the extra segment. Then for string instructions mean if data is present in continuous memory location, more than 1 memory location, more than 2 memory location, or maybe like 10 memory locations. If you want to do a string operation, if you want to transfer a block of data of 10 block of data from one memory location to the other memory location, there for string instruction extra segment becomes very important, because you can directly initialize the data segment and the extra segment, and you can transfer the data. If you want to compare 2 data strings, okay, if you have 10 blocks of data in the data string, if you have 10 blocks of data in the extra segment, so what will happen is that you can easily compare these 2 strings with a single compare string instruction, and it makes it much more simpler, much more easier to compare 2 strings in 8086 because of this extra segment. Then we have stack segment. Stack segment, as you know, is kind of a temporary storage of data and addresses. Whenever there is a jump instruction, usually the microprocessor itself will store the return address. So whenever the program is going to jump from the main program to a subroutine program, the sequence of execution will transfer from the main program to the subroutine program, smaller program. So if there are small functions which needs to be repeated, or delay, if I call it as a delay program, if after switching on an LED, you want to have a delay. So delay is a program which you will be repeated again and again after if you want to switch on and off an LED. So in that case, what will happen, this delay program is executed again and again. So we make it not a part of the main program but a subroutine program which will be called when required. So when the microprocessor gets a jump instruction, what it does is that it goes to the subroutine program from the main program and then executes the subroutine program, finishes the subroutine program, and it has to come back to the main program. To come back to the main program, it needs to know the comeback address, the return address. And to save that return address, what it does is that it uses the stack memory to save that address. Okay, that is one of the things, one of the uses of stack segment. You as a user, if you want to do something, and what happens is that you have some data which needs to be temporarily stored somewhere, you can do that in the stack segment. So stack segment is a memory which will be stored in the reverse order. It's kind of a last in, first out. So whatever you put last can be taken out from the first. So that is stack segment. So memory is divided into 4 segments, like code segment, data segment, extra segment, and stack segment. Each segment is 64 KB, and in total it will be like 1 MB of memory, which can be interfaced with 8086. So as we discussed, there is a 16-bit data line and there is 20-bit address line, but there are no registers which are 20-bit long in 8086. So how the microprocessor generates this 20-bit address is that it uses 2 registers for each memory segment. So there is a code segment CS and IP, that instruction pointer. Then there is data segment and source index, then extra segment and destination index. And there is stack segment and stack pointer and base pointer, which will be used to generate the 20-bit address. So if the microprocessor needs to access the first instruction, what it does is that it uses 2 registers, code segment and instruction pointer. These 2 registers are 16 bits long. Then it will generate the 20-bit address with the help of these 2 registers using the formula segment address into 10 hex plus offset address. So code segment into 10 hex plus IP will give you a 20-bit address, and this 20-bit address is the memory location from where the first instruction is to be fetched. Okay, so whenever the program is to access some kind of data, so whenever in the program you need to access some kind of data, you can use data segment to store your data, and to access those data you will be using data segment register and the source index register. So again, data segment register into 10 hex plus the source index register will give you a 20-bit address of where the data is stored. Okay, same way extra segment and destination index will also work in the same way, and the stack segment and stack pointer will also work in the same way, where these 2 registers, 16-bit registers, will help you to generate a 20-bit address. Without the 20-bit address, you will not be able to reach the memory location where you want to access the data from. So let us see an example. If a segment address is 2000 and the offset address is 3000, so you need to calculate the physical address. You can just pause the video and just calculate. So the answer is 23,000. Okay, so simple as that. So 2000 into 10x plus 3000, that is 23,000. So even if the address is different, if the segment address is 2300 and the offset address is 00, then also the physical address will be 23,000. So even if the value of the offset and the segment address is different, but the physical address is the same. Okay. So again, one more question. 1 2 3 4 is the segment address, the offset address is 5 6 7 8. You can again pause the video and see if you are able to answer this. So the answer would be 179B8 hex. So segment address in alone is not enough. Offset address alone is not enough. Both the addresses are important for generating the physical address. So if in the question you have the physical address 11,000, can you generate the segment address and the offset address? So you can have 1000 1000 or 1100 and both are correct, because eventually the physical address generated by the microprocessor are the same. So it does not it is not wrong if two students have two different segment address and two different offset address. Physical address has to be same. So thank you. So this was a small overview of memory segmentation in 8086. So if you have any doubts, you can put it in the comments. I can reply to that. So thank you very much. See you in the next video.